Okay, so given 10 grams of aluminum carbonate, find the moles of aluminum carbonate and then a whole bunch of other things. So first let's look at what aluminum carbonate is. Aluminum has a +3 charge. Carbonate is the polyatomic ion CO3. It has a -2 charge. So if you're using the crisscross method, we know that aluminum carbonate is Al2CO3 3. So I'm going to color code my work with the different questions here. Part A, they want moles of aluminum carbonate. Well, we have the grams of aluminum carbonate. We want the moles of aluminum carbonate. So we just use grams equals moles times molecular weight. I can plug the 10 grams in. I'm leaving off the 0.00 because that doesn't change the value. I'm solving for moles and I need the molecular weight of aluminum carbonate. So aluminum, I'm going to do it up to the right here. We have 2 aluminums from the subscript. The molecular weight is 27. 3 carbons that each have a molecular weight of 12. 9 oxygens that each have a molecular weight of 16. That gives us a molecular weight of 234. So when I solve this, I'm doing 10 divided by 234 in my calculator. That will get me moles of aluminum carbonate, since that's what I had the grams and the molecular weight of. 10 divided by 234 is 0.0427. If you had rounded that to 0.043, that's fine, no big deal. And that's what they're looking for in part A. So that would be our answer. I'm going to go ahead and erase my work for the molecular weight. You can always rewind the video if you want to see that again. Now, part B, they're asking for the molecules, the number of molecules. So for part B, just the fact that they're asking for molecules tells me that we can use the number sign formula. Number equals moles times Avogadro's number, 6.02, times 10 to the 23rd. When they say molecules, the word molecules always means the whole compound, not just a singular element. That's when we would use the word atoms. So we're solving for that number sign. And since I want it of molecules of the whole compound aluminum carbonate, I need to use the moles of aluminum carbonate, which I just found in part A. So we're plugging our answer in. If you got the wrong answer to A, but then you plugged it into the right spot, you could get full credit on part B. So what I'm doing is, without actually deleting it from my calculator even, I'm just going to take my previous answer, the 0.0427. I'm going to press times 6.02 times 10 to the 23rd. And so that gets me 2.57 times 10 to the 22 molecules. That would be my answer for B. For part C, we want atoms of carbon. Now, that means we know something about the whole that's related. We know the molecules of aluminum carbonate. In fact, I could even write that more clearly here, that it's the molecules of aluminum carbonate. To get the atoms of carbon, carbon is just one part of that aluminum carbonate molecule. So to go from molecules to atoms, whole to part, all I have to do is take my number of molecules that I just found, and I'm going to multiply it by the subscript of whatever part I care about. So in this case, carbon. Looking at aluminum carbonate, I can see that there are 3 carbons. So I take my molecules and I multiply by 3. That gets me a value of 7.7 times 10 to the 22 atoms of carbon. Same idea for part D. Oxygen is just a different part of aluminum carbonate. So again, I take my molecules of aluminum carbonate, but this time I'm going to multiply by oxygen subscript. So we actually have 9 oxygens in this compound. Make sure in your calculator you're going back to the 2.57 number and multiplying by 9. So then we get 2.32 times 10 to the 23 atoms of oxygen. So we can do that going from molecules to atoms like I did in part C and D, using the molecules of the whole thing. We can also do that for part E to a certain extent with moles of a part. So in part E, we want moles of aluminum. Aluminum is one part of my whole thing. I can go from moles of the whole to moles of the part by multiplying by the subscript. I'm just now, instead of using my molecules, I'm going to use my moles of the whole. And then I can multiply by the subscript, in this case of aluminum, which is 2. And that's how I get 0.085 about. That's it.